My name is Andrew Ahn. I'm the Chief Medical Officer at LabFront. And today I'll give the third talk in our Wearables and Sleep Research series. And we'll be diving deep into photoplethysmography fundamentals from physics to physiology. So before we proceed with the talk, let me first briefly remind you of our broader webinar series, which spans the full spectrum of sleep sciences, all from a wearable perspectives. In our last talk, we discussed advanced sleep actigraphy with a focus on sensor and signal preprocessing. And today we'll be talking about PPG as shown here in blue. So these are the objectives for today's talk. My expectation is that by the end of this talk, you will be able to do the following: understand why green light PPG is less susceptible to motion artifact compared to red light PPG, recognize the existing limitations for reflectance PPG in assessing oxygen saturation, appreciate the differences between ring versus wristband-based PPG, and to explain why skin tone, which is based on melanin, does not typically change heart rate or heart rate variability quality, but can diminish oxygen saturation qualities. So I've divided this talk into 5 areas. And the first one is going to be intro to PPGs. And next would be PPG theory and biophysics, sort of understanding the differences between red versus green light PPG, physiological measures that you can acquire from the PPG, and also factors that are involved with PPG, which include body site and skin tone. So I personally have trouble pronouncing this word, but I just try to remember that the emphasis is on MO. So it's photoplethysmography. And the word is derived from the Greek term photo, which means light, plethysmo, which means enlargement. You could think of plethora. And then graphy, which means writing and representation. So photoplethysmography literally means light-based measurement of volumetric changes of blood, which I think succinctly captures its method and purposes. It reflects how PPG uses light to detect variation in blood volume in the microvascular tissue caused by pulsatile blood flow. And the first documentation of PPG was a publication in 1937 by the physiologist Ulrich Hertzmann at St. Louis University. He coined his instrument the photoelectric photoplethysmograph, which is displayed here in figure 1. And you can see the actual PPG signal from the finger in figure 3 from the original publication here. It's represented by the small pulses in this time series. And the one below is actually measurement of respirations. And he did this in 3 different scenarios. And although PPG was considered an interesting tool, the waveform obtained from the PPG was really never intensively studied until the discovery of pulse oximeter in 1974. And so the first pulse oximeter, basically using PPG to derive oxygen saturation, not just heart rate, was first developed in PPG by Takuo Aoyagi, an electrical engineer at Nihon Koden Corporation. And then he had the brilliant idea of using the ratio of pulse changes in red and infrared spectral regions to calculate oxygen saturation. And it proceeded to develop a dual wavelength ear pulse oximeter, which is depicted here. And the reason this was a huge breakthrough for medicine is because it helped bypass the need for arterial blood gas, an invasive procedure to assess oxygen levels in arterial blood. And anyone here who works in the hospital knows how challenging this procedure can be. The radial artery can be often difficult to locate. It can be painful for the patients. And then you kind of need to keep the blood sample on ice and to quickly deliver it to the lab for measurements. And the other important development is that you can monitor oxygen saturation in real time. So you could see this on a sort of a typical display monitor, often seen by the hospital bed, is because, and you can see it here, so it's 99%. And it is because the pulse oximeter often displays the pleth or the PPG signals that the study of PPG signals itself became a subject of clinical interest. Now, wearable technologies really has revolutionized and really expanded the use of application of PPG in just a few years. And the first major breakthrough came with the introduction of heart rate monitoring in the NEAL Alpha watch back in 2012. This paved the way for other major players like Garmin, Samsung, Fitbit, and Apple to integrate similar functionality into their devices. And the second wave of innovation came with the addition of oxygen saturation measurements, or SpO2 monitoring. And the first to offer this was the Withing Pulse O2 in 2014. But in reality, this technology has been only truly available to consumers within the 2020s. For instance, the Apple Watch introduced their SpO2 feature as recently as 2020. However, it's really worth noting that the Apple Watch does not currently offer oxygen saturation monitoring in the United States due to a patent conflict with Masimo. And lastly, the COVID-19 pandemic really changed things up. It served as a major catalyst for public interest in blood oxygen monitoring. And this led to an explosion in consumer wearables equipped with pulse oximeter features, particularly over the past few years. So when we look at the physiological measures available through Garmin, whether on the Garmin Connect app, and you could see sort of the list of physiological measures here, or the more granular Labfront Companion app, which we offer, it's really fascinating to see how much is derived from just the two hardware components in their smartwatches. The first is the accelerometer, and the second is the PPG sensor. The accelerometer plays a key role in activity monitoring, which makes sense. It's responsible for tracking your daily activity summary, step counts, and also even sleep duration. Although, as discussed in my last talk, the sleep classification provided by the accelerometer is limited to wake versus sleep categorization and not sleep stages. On the other hand, the PPG sensor really stands out in its versatility. It's responsible for heart rate measurements, which are then used to calculate additional metrics like stress, which I think is somewhere here. Yep. And even calorie counts for certain activities. Beyond that, the PPG sensors also provide the data needed for sleep staging, respiration rate, and oxygen saturation. And so you see it on both sides, both in the Garmin Connect and the Labfront Companion app. So in fact, PPG can theoretically provide a really full array of physiological parameters, many of which are highly relevant to sleep, but still remain an active area of research. And these parameters include pulse rate variability, autonomic nervous system activity, particularly parasympathetic nervous activity through pulse rate variability, cardiac rhythms and arrhythmias. It's pretty good for oxygen saturations, as discussed before, for sleep time and duration and stages, for respiratory rate and respiratory events such as arousals, because when you are aroused in the middle of the night, it causes sympathetic contraction and causes the PPG signals to actually diminish. And it can also provide information about blood pressure and arterial stiffness and endothelial function. So you could see that the PPG really is an active area of research. And I would say the areas that are demarcated here with the asterisks are areas where there's significant amount of validation done in this area.